Have you ever wondered what makes up most of the universe you can't see? We're talking about a vast, unseen part of our cosmos, a hidden dimension that holds the universe together yet remains shrouded in mystery. It's called dark matter. Now, don't let the name fool you. It's not dark because it's evil or ominous. It's dark because it doesn't interact with light. It's like the shy kid at the party, always there, but never really making itself known. We can't directly observe dark matter, but we know it's there. How, you ask? Well, through its gravitational effects. This unseen substance is the puppet master, pulling the strings of galaxies and bending light in ways that boggle the mind. And here's the real kicker. All the stars, planets, and galaxies that we can see make up just a tiny fraction of the universe. So, the universe we know is just a tiny fraction of what's out there. So, what exactly is this elusive dark matter? Let's embark on a cosmic journey to understand this invisible yet incredibly significant aspect of our universe. Imagine you're in a room and there's a ghost. You can't see it, feel it, hear it, or smell it, but you know it's there because every now and then a book flies off a shelf or a chair mysteriously moves. That's a bit like dark matter. It's there, and we know it's there because we can see its effects, but we can't directly observe it. Now, why can't we see dark matter? Well, it's because it doesn't interact with light or electromagnetic radiation. Just like our ghost in the room, dark matter is invisible to the naked eye and even the most sophisticated scientific equipment. It's like trying to see air, but even more challenging because air, at least, interacts with light. But if we can't see it, how do we know it's there? That's where things get interesting. We see its gravitational effects on visible matter, on galaxies, and on the universe as a whole. Picture a massive cosmic ballet where all the dancers are moving in sync, but there's an unseen force guiding them. That's dark matter. Moreover, dark matter isn't just a small part of the universe. It's estimated to make up about 85% of the matter in the universe. Yes, you heard that right. 85%. It's the invisible backbone that holds the universe together. So, despite being elusive and invisible, dark matter is an integral part of our universe. We can't see it, but we can certainly feel its presence in the cosmic dance of galaxies and the grand structure of the universe. Dark matter might be invisible, but its impact on the universe is profoundly visible. It's the ghost in our cosmic room, silently shaping the universe as we know it. But how did we come to know about something we can't see? Our journey into the unseen begins in the early 20th century with a Swiss astrophysicist named Fritz Zwicky. Now, Zwicky was a bit of an eccentric character, but his mind was razor sharp. And it was his observations in the 1930s that first hinted at the existence of dark matter. Zwicky was studying a group of galaxies known as the Coma Cluster. He noticed something peculiar. You see, galaxies are bound together by gravity, and the speed at which they move around each other depends on the total mass of the cluster. When Zwicky calculated the mass of the Coma Cluster based on the galaxies he could see, the numbers didn't add up. The galaxies were moving too fast, as if there was a lot more mass in the cluster than what Zwicky could observe. This was a puzzle that perplexed Zwicky. He thought, what if there was matter that we couldn't see? Matter that didn't emit or reflect light, but had gravity. He called this unseen matter Dunkel Materie, or dark matter. Now, this was a revolutionary idea, and like most revolutionary ideas, it wasn't accepted immediately. In fact, it was largely ignored for decades. But as more and more observations across the universe started showing the same discrepancy, the idea of dark matter became harder to ignore. The concept of dark matter is a humbling reminder of how much we have yet to learn about the universe. It challenges our understanding of the cosmos, pushing us to question our assumptions and explore new theories. From the earliest days of human history, we've looked up at the stars in wonder, telling stories about the patterns we see. But it was the careful observation and curiosity of people like Fritz Zwicky that turned these stories into science. As Zwicky himself once said, we should not be surprised when we find the universe to be more complicated than we imagine. The stars were telling us a story, but it took a keen observer to understand it. Why does dark matter matter to us, you might ask? Well, dark matter plays a pivotal role in our universe's grand scheme. It's the invisible glue that holds galaxies together, forming a cosmic web that underpins the large-scale structure of the universe. Imagine a universe without dark matter. Galaxies would simply drift apart, unable to congregate into the grand structures we observe today. But with dark matter, these galaxies have a gravitational anchor, pulling them together into intricate patterns that span billions of light years. Understanding dark matter isn't just about appreciating our universe's present state. It's about peering into the past, tracing the cosmic fingerprints of dark matter back to the universe's infancy. It's about predicting the future, forecasting how the universe will evolve and transform under dark matter's subtle influence. So while we may not see dark matter, we can't ignore its profound impact. Dark matter may be unseen, but it shapes our universe. So where do we go from here in our quest to understand dark matter? Great strides are being made in our pursuit for the unseen. Scientists worldwide are striving to detect dark matter directly and indirectly. One such effort is underway at the Large Hadron Collider, where researchers are smashing particles together at almost the speed of light, hoping to create and detect dark matter. Meanwhile, up in the cosmos, the James Webb Space Telescope is scanning the universe, searching for the first stars formed from dark matter. These dark stars, as they're called, could provide invaluable insights into the nature of dark matter. Such ongoing efforts are pushing the boundaries of our knowledge, and we stand on the cusp of potential breakthroughs. The future of dark matter research is promising, teeming with possibilities and ripe for discovery. The universe has many secrets, and dark matter is one of its biggest. But with every passing day, we get closer to understanding this cosmic enigma.